Welcome to the Excellence in Enterprise podcast, where I reach out to people I do not know, engage with friends, all for the purpose of learning about them, learning about what they care about, why they care about what they're doing, what they're engaged with from across multiple different industries and multiple different vantage points and viewpoints, all for the purpose of increasing my personal knowledge and kind of thinking outside the box when it comes to my work, my professional career. I want to draw from those sources, and I thought you might be interested in hearing as well. So I hope you will join me on this journey. You can find me on YouTube, on Spotify, on Instagram, and on Twitter. Feel free to reach out anytime. I'd love to engage with you. And I hope you enjoy this podcast interview engagement journey with me. Welcome back to episode number 9 of the Excellence in Enterprise podcast. I brought back Carter Davis as my first repeat guest for this particular episode, and I was actually not planning on doing any repeats in the first year of the podcast, but I wanted to know a little bit more about the crypto world, and Carter, with the software developer background and crypto mining background, I thought he might have some useful information and be able to provide a little bit more understanding as to the technical background behind crypto, so that I could better understand how it works, use case scenarios, and hopefully develop a little bit better understanding of its potential and, in theory, likely impact on the world around us. And so I hope that you enjoy our conversation for that reason as well. If you want to know a little bit more about Carter, please go check out episode number 2 of the podcast. He was actually the very first guest I had on here, and he actually has a very interesting background, from drumming to professional Call of Duty and a whole bunch of other things like that. So go check that out. And then as we get into the episode, I did want to let you know, Zoom kind of did a dirty one on us and kind of had some weird audio stuff in the recording back and forth. I'm not sure exactly what caused that. It's the first time it's happened to me, but I hope you'll bear with it and don't mind too much. Thank you so much. And let's get into the episode. When I think of the beginning of crypto, like the most fundamental element, it is the development or the original development of, say, Bitcoins or Ethereum's or whatever's coins algorithm. Is that an accurate place to start?
Yeah, I don't know if that's necessarily the beginning. I'd actually be interested to see what like these core blockchain developers discuss when they start. I have a feeling the algorithm of like how they're going to accomplish this consensus. So when we speak about algorithm, I think it's important that we understand, most of the time we're talking about it in the blockchain space, about a consensus algorithm. How do we have all these different nodes that agree on what's happening?
Okay, and so then what's a node?
So a node, generally, I mean, it depends. Like sometimes I've seen like nodes where it's an interface into the blockchain. There's other aspects such as a node, like a mining node. It depends on the context, but generally, like those are two different, I guess, entities that we could think about. So one like mining node is going to be something that's helping verify the transactions. So I actually have the Bitcoin white paper pulled up here, so I can make sure I read this off word for word. So the way this algorithm works is this is under point number 5 on the Bitcoin algorithm. If you just search like Bitcoin white paper, you can find this. So number 1, so new transactions are broadcast to all nodes. So I transfer money to you. I'm going to broadcast a transaction to you. Each node collects new transactions into a block. So a block is basically a set of operations, and generally they're somewhat in order. And then we can assume that anything that occurred in a previous block occurred in a previous point in time. So new block is later in time, whereas previous blocks were more previous in time. Mm-hmm. They happened longer ago. And then each node is going to work on finding a difficult proof of work for its block. So I don't want to get too bogged down into proof of work. It's I think one of the problems that I have with this space right now. But the idea is proof of work is a hard math problem to solve. Whoever solves the hard math problem first is going to be the one to solve the proof of work for that block.
Gotcha. And is the speed of the processing and the solving based on the quality of your equipment and its ability to process the functions of the math within the algorithm more quickly? Or how does, why is someone, why is miner one getting it versus miner two?
Awesome. Yeah. So sometimes it's random. Sometimes it's not necessarily the speed, to my understanding, though I think that helps. To my understanding, it's a lot about the parallelism of computing it. So that's why things like GPUs are popular in this, because we can compute many operations at a single time instead of using like a CPU where we're just computing one operation after another after another. And yeah, sometimes it's random. Sometimes it's literally just, hey, I'm working on this chunk of inputs, and sometimes it's, hey, I'm working on that chunk of inputs, and that one happened to have a correct input.
Okay. And is the algorithm operating those functions, or are they sitting on top of the algorithm?
So I guess like the algorithm is kind of what I've started to outline here. I would say it's a like substep of the algorithm. Like the proof of work algorithm is probably at least like the hashing portion of it. I've looked into it before. I don't know. I don't remember how complicated it is, but that has to do with math and nerd stuff, and I don't know, whole lot of math. So
Okay. Gotcha. And okay, so I'm trying to process here. So when it comes to the, you're sending me a transaction, and that, but in order for it to get to me, it's going to multiple miner units, nodes, right? And a single miner can have multiple nodes.
um, I guess in this case, let's think about the best way to I guess sort of model this. So like a single mining entity. So let's say like I am going to start mining Bitcoin or whatever. I can have multiple machines mining that all belong to me. Yes.
Okay. And is each machine considered its own node, or are multiple nodes running on a single machine, or is each individual miner represent a node
So
with greater or lesser capacity?
I guess in this context, like as far as the white paper defines it, I mean this is where it gets like kind of mixy of like what is a node. Like I don't know. Like there's such thing as nodes that are not miners, that have separate purposes, but um, excuse me, in the case of like the white paper, if that's strictly what we're talking about, I believe the white paper considers every node to be a miner and every miner to be a node.
Okay. Gotcha. And when it comes to the various types of nodes and their purpose, is that like, was that designed in the original algorithm, or are those things that have been built into and on top of the original Bitcoin, Satoshi algorithm?
I'm sorry, can you repeat the question? I'm not sure I understand.
So is the definition of a particular node, say one node equals one miner and vice versa, is that is that designed and part of the original algorithm that was developed, or are those kind of computations and external algorithms and executions, I guess, being built on top of the original algorithm? So as far as like modern day implementation goes, maybe this will answer it. So miners are what perform this algorithm to solve these computations and try to prove that these transactions exist and are valid. Okay.
The idea behind it is that basically, since it's like a big competition, right? And that's where the security of the Bitcoin blockchain comes from, is that there's a lot of competition on it right now, and so it's very, in order to create like a dishonest 51% attack is what we would call it. You would have to have 51% of the network's power, which is quite a bit right now. And honestly, I don't know that it's necessarily physically possible right now. I mean, it's probably physically possible, but I don't know if it's like literally like, I don't know, figuratively possible. Let's put it that way. So, and then a node is like, it it's something that stores the information of the blockchain. It stores all of these blocks and all this data, and then it runs a client software that checks to confirm that all of these transactions confirm to the protocol. That is the like Wikipedia definition of it. Now, I know, I don't know, I know like in modern day there's nodes and there's miners and they're different, but like I said, as far as the white paper is concerned, it defines a node as a miner and a miner as a node. They're both the same thing.
Okay, gotcha. And what is the miner's incentive to drive the competition or to be a part of the competition? Is it that they just get a piece of, say, the Bitcoin, a piece of the transaction as a result of being able to process it, or what?
So they actually get what's called a block reward. So basically, if you're the first one to solve this proof of work algorithm, and like provide a valid solution, then you get what's called a block reward. And that reward, the amount of it changes every few years. And that's actually something that is probably the biggest driving factor in the entire cryptocurrency market, something called the halvening cycle. So every few years there's, and I don't remember exactly what defines the halvening. I believe the next one's in 2024. But basically the halvening is when the block reward is cut in half. And so that creates more scarcity to Bitcoin. So essentially, every few years, there's less and less that's being mined throughout the next few years. And eventually that number is going to hit zero.
Okay. So let's see if I can, throw this back at you. So there is the block, which is the overall totality of the Bitcoin algorithm, which is then broken up into X amount of individual Bitcoins, which, like, I think the total number you can mine is like 21 million or whatever it is, something like that. Is that so far correct?
I would say a block is more of a set of transactions that happen at a given.
Word. All right. Cool. All right. So word. All right. Cool. All right. So we're going to dive straight in on this one. I've kind of cut out like my intros, and I'll do like a post production video and then record that or whatever, talking about like a summary, and that way we can dive in. So, okay, cool. So yeah, the reason that we're doing this podcast, first of all, you're the first repeat guest, which I wasn't even planning on doing within the first year, but you're the only person that I know who knows much of anything, at least on, relatively speaking, about the technical side of cryptocurrency. And what a day to have planned to record it, because everything dropped like 20 to 50% today and then rebounded a little bit. So it's all over the place, but very down this morning and throughout the day. So hopefully, we can use this to calm everybody down, and people can kind of figure out what's actually going on. So to dive in, and Carter, I guess, in case people haven't watched the very first episode, is he's a software programmer, developer, and that's his full-time job and what he studied in school. He's got a lot of other things. If you want to learn more about Carter, go watch the first episode on the podcast, and then we're going to stick to focusing on doing our best, or me doing my best, to understand crypto and how it works, and at least at a high level. I think one of the things that we've briefly discussed is how complicated the whole thing is, which is part of why I want to at least try to understand what I can. And I've done certainly a lot of reading and a lot of research and listened to a lot of different podcasts and interviews and all kinds of stuff like that. So I generally understand some of the application aspects of it from a macroeconomics perspective. And we'll get more into the use cases, kind of later on in the conversation. But to start us off, So if, I guess to start us off, trying to and tell me if there's a different place we should start relative to the beginning. But when I think of the beginning of crypto, like the most fundamental element, it is the development or the original development of, say, Bitcoins or Ethereum's or whatever's coins algorithm. Is that an accurate place to start?
Um, yeah, I don't know if that's necessarily the beginning. I'd actually be interested to see what like these core blockchain developers discuss when they start. I have a feeling the algorithm of like how they're going to accomplish this consensus. So when we speak about algorithm, I think it's important that we understand. Most of the time, we're talking about it in the blockchain space about a consensus algorithm. How do we have all these different nodes that agree on what's happening?
Okay. And so then what's a node?
So a node, generally, I mean, it depends. Like sometimes I've seen like nodes where it's an interface into the blockchain. You know, there's other aspects such as a node, like a mining node. It depends on the context, but generally, like those are two different, I guess, entities that we could think about. So one like mining node is going to be something that's helping verify the transactions. So I actually have the Bitcoin white paper pulled up here, so I can make sure I read this off word for word. So uh, the way this algorithm works is this is under point number 5 on the Bitcoin algorithm. If you just search like Bitcoin white paper, you can find this. So number 1, so new transactions are broadcast to all nodes. So I transfer money to you. I'm going to broadcast a transaction to you. Each node collects new transactions into a block. So a block is basically a set of operations, and generally they're somewhat in order. And then we can assume that anything that occurred in a previous block occurred in a previous point in time. So new block is later in time, whereas previous blocks were more previous in time. Mm-hmm. They happened longer ago. And then each node is going to work on finding a difficult proof of work for its block. So I don't want to get too bogged down into proof of work. It's I think one of the problems that I have with this space right now. But the idea is proof of work is a hard math problem to solve. Whoever solves the hard math problem first is going to be the one to solve the proof of work for that block.
Gotcha. And is the speed of the processing and the solving based on the quality of your equipment and its ability to process the functions of the math within the algorithm more quickly? Or how does, why is miner 1 getting it versus miner 2?
Awesome. Yeah. So sometimes it's random. Sometimes it's not necessarily the speed, to my understanding, though I think that helps. To my understanding, it's a lot about the parallelism of computing it. So that's why things like GPUs are popular in this, because we can compute many operations at a single time instead of using like a CPU where we're just computing one operation after another after another. And yeah, sometimes it's random. Sometimes it's literally just, hey, I'm working on this chunk of inputs, and sometimes it's, hey, I'm working on that chunk of inputs, and that one happened to have a correct input.
Okay. And is the algorithm operating those functions, or are they sitting on top of the algorithm?
So I guess like the algorithm is kind of what I've started to outline here. I would say it's a like sub step of the algorithm. Like the proof of work algorithm is probably at least like the hashing portion of it. I've looked into it before. I don't know. I don't remember how complicated it is, but that has to do with math and nerd stuff, and I don't know, whole lot of math. So
okay, gotcha. And okay, so I'm trying to process here. So when it comes to the, you're sending me a transaction, and that, but in order for it to get to me, it's going to multiple miner units, nodes, right? And a single miner can have multiple nodes.
I guess in this case, let's think about the best way to I guess sort of model this. So like a single mining entity. So let's say like I am going to start mining Bitcoin or whatever. I can have multiple machines mining that all belong to me. Yes.
Okay. And is each machine considered its own node, or are multiple nodes running on a single machine, or is each individual miner represent a node
So
with greater or lesser capacity?
I guess
In this context, like as far as
the white paper
defines it, I mean this is where it gets like kind of mixy of like what is a node. Like I don't know, like there's such thing as nodes that are not miners, that have separate purposes. But excuse me, in the case of like the white paper, if that's strictly what we're talking about, I believe the white paper considers every node to be a miner and every miner to be a node.
Okay, gotcha. And when it comes to the various types of nodes and their purpose, is that like, was that designed in the original algorithm, or are those things that have been built into and on top of the original Bitcoin, Satoshi algorithm?
I'm sorry, can you repeat the question? I'm not sure I understand.
So is the definition of a particular node, say one node equals one miner and vice versa, is that designed and part of the original algorithm that was developed, or are those kind of computations and external algorithms and executions, I guess, being built on top of the original algorithm?
So as far as
Like modern day implementation goes, maybe this will answer it. So miners are what perform this algorithm to solve these computations and try to prove that these transactions exist and are valid.
Okay.
The idea behind it is that basically, since it's
like
a big competition, right? And that's where the security of the Bitcoin blockchain comes from, is that there's a lot of competition on it right now, and so it's in order to create like a dishonest 51% attack is what we would call it. You would have to have 51% of the network's power, which is quite a bit right now. And I honestly, I don't know that it's necessarily physically possible right now. I mean, it's probably physically possible, but I don't know if it's like literally, like, I don't know, figuratively possible. Let's put it that way. So, and then a node is like, it's something that stores the information of the blockchain. It stores all of these blocks and all this data. And then it runs a client software that checks to confirm that all of these transactions confirm to the protocol. That is the like Wikipedia definition of it. Now, I know, I don't know. I know like in modern day, there's nodes and there's miners and they're different. But like I said, as far as the white paper is concerned, it defines a node as a miner and a miner as a node. They're both the same thing.
Okay, gotcha. And what is the miner's incentive to drive the competition or to be a part of the competition? Is it that they just get a piece of, say, the Bitcoin, a piece of the transaction as a result of being able to process it, or what?
So they actually get what's called a block reward. So basically, if you're the first one to solve this proof of work algorithm, and like provide a valid solution, then you get what's called a block reward. And that reward, the amount of it changes every few years. And that's actually something that is probably the biggest driving factor in the entire cryptocurrency market, something called the halvening cycle. So every few years there's, and I don't remember exactly what defines the halvening. I believe the next one's in 2024. But basically the halvening is when the block reward is cut in half. And so that creates more scarcity to Bitcoin. So essentially, every few years, there's less and less that's being mined throughout the next few years. And eventually that number is going to hit zero.
Okay. So let's see if I can, throw this back at you. So there are there is the block, which is the overall totality of the Bitcoin algorithm, which is then broken up into X amount of individual Bitcoins, which, like, I think the total number you can mine is like 21 million or whatever it is, something like that. Is that so far correct?
I would say
A block is more of a set of transactions that happen at a given time.
Okay.
So let's see. I believe I don't remember the block time for Bitcoin right now. I believe
It's around 10 minutes, I think.
yeah, that sounds correct. Yeah, so basically a block is going to be a history of all those transactions that have occurred between the time that the block is published and the previous block.
Yep. And so when a miner is getting rewarded, they're getting an X percentage of the unmined Bitcoin, essentially. Correct?
um, I guess
That's correct. I mean, generally it's like a flat amount for the given, halvening cycle.
Gotcha.
So
Okay. But they're getting I guess the easy way of saying it, or, addressing it, is that they are getting a part of the unmined Bitcoin, whether, whatever is defining that. And so then they can then hold that Bitcoin and then sell it and put it back into the transactions, which is how they're able to make, say, cash or whatever. But essentially they could sit on the Bitcoin that they're getting from this mining.
yeah.
doing some fact checking. Right now, the current block reward looks like it's 6.25 Bitcoin.
Okay.
And the thing that defines the happening is every
210,000
blocks.
Okay. Gotcha. And a block is a set metric, essentially.
Yeah, it's a
Set of transactions.
Okay. And relative to the halvening, I believe it's driven by the rate at which the Bitcoin is being mined. And so, or sort of, it's because the faster it's being mined, the slower the algorithm actually allows it to process, essentially. Correct?
Yeah, so
there's a concept of difficulty, and I don't remember exactly how it's computed, but basically it defines how hard it is to define to solve these mathematical problems.
Yeah.
And it can increase or decrease depending on the network strength, basically. So if there's a lot of competition like there is right now, and there's tons of application specific miners, generally known as ASICs, then that difficulty is generally going to be pretty high. But in the early days of Bitcoin, when people were mining it with their CPUs, that difficulty was pretty low.
Gotcha. Okay. And so it's essentially the algorithm, which I feel like we're just, describing the matrix here, is self-governing the speed and the distribution of Bitcoin.
Yep, that's correct.
And that's based on whatever essentially mathematical metrics that Satoshi originally came up with.
Yep.
Okay. So, all right, that's perfect. Okay. So we talked a little bit about proof of work. What's the difference between proof of work and proof of service?
Sorry.
Are you referring to proof of stake?
Proof of stake. Sorry, wrong S word.
Yep. So
proof of stake, high level overview. Proof of work is competition between everyone. Proof of stake is you put some money up for stake. In this case, the native currency of whatever chain it is. And you promise real hard that you'll be cool and that all these operations are valid. And you randomly get checked against other nodes. So I forget the current implementation that's planned for the Ethereum blockchain, the most popular blockchain moving to proof of stake here soon. But you basically get randomly selected with a subset of nodes. So instead of all of the nodes, you're now working with a handful of other nodes. And if you all come to the same conclusion, then that you get a reward. But if you're dishonest, you lose what you put up.
Gotcha. Okay. Interesting. Okay. Yeah, that is very interesting. Okay. So, but the reason it's faster is because it's not being constantly checked against the whole history of the algorithm. Or of the block. It's just being checked kind of randomly.
Yeah, and
My understanding, you're like, since it's a subset of nodes, like, and every node is running constantly, I'm assuming that transactions can happen more concurrently. Maybe blocks can be validated a little quicker. I'm not entirely sure on that, but that's kind of my high level understanding of it.
Gotcha. Okay. So when it comes to me putting down, like, say I go on an exchange, whether it's Binance, Coinbase, Gemini, whatever, and I put $100 into that exchange, they then exchange that for a 0.00 whatever it is percent of a coin, or right, then that coin is now in my wallet, and at least or it's within the exchange, and then you can transfer it to a private wallet or whatever. So I guess the next question that I have, which is for the sake of clarity, is there is no real, obviously it's not a true, it's only a digital entity, right? It's the same as essentially owning part of a JPEG picture for us laymen, right? And so the value, the overall value to the individual who wants to own some, quote unquote, as much as you can own something that's digital in the first place, is that more and more people want access to it, and or more people are using it for exchanges of value, whether I'm paying Tesla with Bitcoin for a car or something along those lines. Is that relatively straightforward?
In theory, yes. In actuality, I mean, it seems lately it's more dependent on like what Elon Musk tweets about it. So yeah, I don't know. Yeah, I'd say that's correct.
Okay. Well, and in theory, Elon Musk tweeting about it is causing people to either sell it, which drives down the amount of demand. Well, it increases it for a short time, and then it drives down the amount of demand for the coin, and fewer people are trying to own it, and then that is what causes the overall fall off in demand. So then I think the next piece of this, I hope, we're speaking very obviously still continuing to speak high level, but the next piece of this is, and one of the things that I've come across, and Ethereum is probably the most ubiquitous example, but of people building things on top of the Ethereum network or the Bitcoin network. And if you like, loud examples are your NFTs. BitCloud is like another kind of variation on the theme, a couple things like that. So I'm curious, what is is that the same thing as building a website on the internet? Like, what is the correlation there, and what's the difference between building a website on the internet and building an NFT on the Ethereum network?
All right, now we're getting more into my territory. So for a while, so I've done a little bit of Ethereum development. I did some in college, did some for research, did some for fun, did some for like some freelance work. So generally, like an application hosted on the Ethereum blockchain, we call a decentralized application, or a DApp for short. It's similar to hosting and like building a website. I see people that generally have web development skills getting involved with this space. It's different in the sense that like we're not hosting our server anywhere. We're hosting our business logic on the Ethereum blockchain by writing what's called smart contracts, which is basically just code that runs on a blockchain. Like there's some really cool tools that have spun up from this. As far as it, generally they're grouped into a set of technologies called Web 3.0. So we can think of different stages of web technology. Web 1.0, that's like your very old school static web pages. There's not much dynamic content on them. Web 2.0 is more like the social media age. We have things like Facebook and Twitter that we see popping up. It's about users creating dynamic content. And then Web 3.0 is more about users owning their security, owning their data, like decentralized technologies that no one really owns.
Okay, gotcha. And okay, so one of the questions that I've had is in trying to pay attention to at least some of this is what is the, I guess, how do you guarantee that, you know, a power outage doesn't wipe out, you know, the 50 nodes that your, you know, that were connected to your, you know, NFT, you know, smart contract? Or is it that because they all exist on the same medium and they're all able to handle the same, you know, the same requests, it's like there is no, like, as opposed to something sitting on a server that can go down and now you don't have access to that server, is it, you know, can you speak to that a little bit?
Yeah. So
Um, and we're really talking about like all these obscure types of nodes today. So I've seen some different labels for nodes, such as like full nodes. I forget like the language that's used for smaller nodes, but essentially, yeah, like you can assume that for the most part, like your application is synced to all the nodes involved. Not just like the ones that it's not correct to say that only specific nodes talk to your application, because your application is hosted on the blockchain and every transaction that happens gets put into a block.
Gotcha. Okay.
so
When I go and I deploy my smart contracts that have my business logic, that gets put in as an operation into a block.
Okay. And there's no, in theory, there's no such thing as overwhelming the nodes by having 100 million different blocks that are built on top of the Ethereum blockchain.
there is actually.
And that's actually one of the biggest problems with this space is talking about what happens at scale. Like, you know, what would happen if today every single user didn't use traditional like Web 2.0 technology and they just started adopting blockchain technology and everything we did was on that? There would be a lot of scalability issues.
Gotcha. And is that a speed thing, or is that also a capacity thing in that, you know, the 100 million miners out there, you know, however many there are, the 100 million miners out there can only, you know, their equipment essentially can only process so many requests or transactions, blocks per day, per hour, per second, etc.
I think a lot of it goes back to the proof of work algorithm. It's slow. It does pretty well with data that isn't really like constantly streamed. Like it does well with small updates that happen every now and then and don't require like instant update. Right? Like if you transfer funds to a user, we're not like live streaming a video through that same technology. As far as I know, like that's pretty much impossible right now. So yeah, it just has to do with the proof of work algorithm, how slow it is, like the competitive nature, the block times. Like it's just hard to handle that many transactions at scale.
Okay. And then I think the other piece is how, you know, and I guess this sort of relates to at least censorship and to some extent or another, but how, let's say the, you know, the fiber internet to Canada, which is where one of, you know, several major mining operations are. Let's say the fiber internet connection gets cut or damaged or whatever, going out to those nodes or to those miners. Does like I guess the problem is that essentially cuts them off in the same way that losing a server would cut someone off, right? Because, you know, when we talk, one of the, and to put this in perspective a little bit, one of the big picture ideas, in which you've mentioned, is this decentralized finance, decentralized security, and all these other things. But it's all still running on the same internet essentially connection. It's the same hardware. It's right. It's I'm logging in from my browser into this, you know, into this exchange, into my wallet, and the only way you can really get off that is if you put your your digital currency, your coins or whatever, onto like an external hard drive or USB device, which you can then remove, but it's still, you can still corrupt it. And once it's corrupted, it's completely gone. Like you can't re-access it.
I'm not sure
I understand the question.
Well, my question was, is that an accurate understanding of the environment?
So as far as
Concern from like losing, internet connection. I like, I don't know, maybe I don't understand, but I don't think that's really.
I guess what I'm saying is like, they're all talking about this from a decentralized security and, even from a censorship perspective, right? If a government says, hey, you don't get access to the internet, it's illegal for your mining company to have access to the internet, for instance, there's no way for that mining company to get around that, in theory, because they have to have access to the internet, right? There's no, like, when we say decentralized, it's decentralized from the standpoint of it's borderline, we'll say borderline impossible to hack, borderline impossible to falsify, but it doesn't get you away from needing access to, the same internet that all of us have access to, essentially, and are used to, at least from like Web 2.0, Web 1.0, and now Web 3.0. They're all running on the same, essentially global internet infrastructure.
So, I don't know. I don't know
How that works, like as far as trying to, I guess, prevent access to that. I'm sure there's like some like network traffic pattern you could do, you could search for and like try to sniff out that would be generic for all mining operations or something like that. I've seen some stuff. There's like this extremist ideology that I've seen where we basically, the argument is we can't have open source like decentralized software until we have open source decentralized networking hardware, etc. And I think that's kind of the point you're trying to make, is like the software is open source and decentralized, but the hardware and the way we like connect to that decentralized software is very centralized. And so yeah, like that could definitely cause problems. And even like one of my complaints lately is like, I mean, what's happened in the market the last week is like we've had really only three big like centralized opinions that have swayed the market so much, right? There's Elon Musk's tweets. Second would be the IRS looking into Binance, and third would be China doing exactly what you're talking about now, where they're trying to outlaw basically anything to do with cryptocurrency, right? And those are only three entities, and they've managed to control the entire market. So yeah, it very much happens.
Gotcha. Okay. Yep. No, that's perfect. I love that answer. That's exactly what I was going for. So the next piece that I want to, and I guess in defense of that, the theory is, hey, if, of the world's 7 billion people, 4 or 5 plus billion start using it, then the governments are going to buy in, right? Like that's the theory.
Okay.
And not to mention it's also not, it's also very difficult to track, if on a Web 2.0 version is like if you're running through a VPN or something along those lines, right? So like there are ways to make it very difficult to get access to it. But I mean, if like if the Chinese government, for instance, knows that, X company X, miner X is, located out of this warehouse, they can go to that warehouse and confiscate the equipment that is processing the nodes and the blocks.
Yeah, and
I think the bigger thing is like, I don't know, a lot of people seem to think that you can't really track anything, which is, it seems backwards to me, because like literally the definition of having like a blockchain is it's like a public record.
Yep.
And so
especially if you do anything like if you buy cryptocurrency on an exchange, whether you send it to a different wallet or not, like you can trace the transaction of you sending it to a wallet, and then you can trace the transactions that happen on the wallet. I forget what happened, but a few years ago there was actually a story like that where there was some like, I don't know, some set of criminals or something that were busted by some government because they were traced back to like an exchange. So I don't know. I mean, it's really easy to track that kind of stuff. What's more difficult, I think, is in the case where like everything, the way you acquire the currency is decentralized. So like maybe if you're a miner and like you don't have like anything linked to a wallet that is linked to some sort of exchange or anything, like, and I know people that have that, like they have a wallet that does not interact with any centralized exchanges, and that's what they mine to. So I don't know, like it's definitely possible to stay like pseudo anonymous because anything that happens on that wallet can be tracked pretty easily. It's just hard to tie that wallet to an individual.
Yeah. Yeah. And I mean, but the other side of that is like, that's going to one direction. As soon as they want to use it and interact back with the system, you're right back into the flow of the, the tracking. So,
Yeah.
okay.
I know
There's been some currencies that have been trying to combat that. I think, yeah. So it's a problem that people have been trying to address, but yeah.
Okay. All right. No, that's really good to know, and I think that's super good information. So then the next piece that I've been trying to figure out, and I understand certain elements of it, which is disagreements between the miners on the best way to execute on top of the blockchain. And the basic question is, why are there 150 billion different coins? Whether it, and Bitcoin and Ethereum are the biggest, but then you've got Cardano, you've got Doge, you've got SafeMoon, you've got, FYN Finance, you've got 1,000 other ones, and then you've got like Gemini, I think, has like their own version, right? And then people are starting to come up with their own coins. Like, why do you have so much actual decentralization? And where is that coming from, and why do people buy into it? Like, why are people willing to buy into SafeMoon, but they're not willing to put that same money into a Bitcoin and an Ethereum?
Yeah.
I don't know. People are idiots. Like, so I see new things pop up in this space all the time, and there's some projects that are really interesting that I think are trying to solve an actual problem and are fundamentally technically sound. Like you read their white paper, and after reading the white paper, you come out of it like, oh yeah, that makes sense. I understand why you're doing this. There are unfortunately a lot of people in this space that just want to make a quick buck, on all sides, like investors, actual people who design these and develop these cryptocurrencies. Like, so I think it's more that there's these developers that want to make a quick buck, and then there's also these investors that want to make a quick buck. And unfortunately, that's just the state that the space is in right now.
Gotcha. Okay. And when it comes to the kind of overall adoption, and now we can talk a little bit more about the specifics, macroeconomics, and like all that fun stuff. When it comes to Bitcoin and Ethereum, from your perspective, is the true value in the technologies that they can act as a store of value, assuming we all buy into wanting to own some, or is it that you can build kind of Web 3.0 applications on top of the technology, on top of the blockchain?
I think so. I think it's a little bit
of both. So one of the ways that I've been explaining this is like the network effect. Like, I forget, there's like a mathematical computation for how valuable a network is. I think it's like the number of nodes squared or something like that. And by nodes, we can assume that nodes means users in this case, right? So
okay.
if I have one user of my blockchain, that's not worth anything. If I have two users, that's worth a little bit because I can transfer value back and forth. But if I have 1 billion users on my blockchain, that's worth a lot because there's a lot of people that I could transfer assets to. So yes, like it's a little bit of that. I think in the case of Ethereum, what makes it so valuable now, in my opinion, is it's almost the same thing with the network effect, but it's with in this case, we're talking about the amount of applications on it, right? There's just so many people that have built something on it. And to me, it just feels like we're just sitting, waiting around for this network to become more viable on the back end with something like proof of stake, where we can actually have these transactions without having these ridiculous like $300 gas fees.
Yep. Gotcha. Okay. So when it comes to, and this is how I've generally been thinking of it, and, correct me from a technical perspective, but I've generally been thinking of Bitcoin as more of a store of value, where if we're all buying into, now I feel like there has to be some sort of practical application, practical use in order for it to be a store of value, because it's, and again, the closest, the closest comparison in real world terms, quote unquote, it's all the real world. Some of it's just more ethereal, is gold. And the idea behind gold is like, I can take a chunk of gold and go virtually anywhere in the world, and someone's going to want that. And because we have this human attraction to it, essentially, and because that person knows they can go anywhere in the world and somebody's going to want it. When it comes to Bitcoin, I feel like it's that store of value application is probably the most realistic, because it doesn't have, and at least, there's two variations on the theme of Bitcoin. There's two different minor fields of thought, one of which is trying to achieve faster blockchain. I think they've talked about proof of stake, and then the other one is sticking to proof of work, and that's what the current Bitcoin is that the vast majority of people own. That's like a market cap of $1 trillion or whatever. So when, like, that's how I've been thinking of Bitcoin. And then when I think of Ethereum, I think of that more as has at least the potential, especially if we move to proof of stake, which I believe is the majority of miners' plan, which I forget what it's called. Like they have a name, Ethereum XYZ for it, but I forget.
EIP.
Yeah, I think that's right.
Yeah.
So basically, there's these like improvements that are proposed for Ethereum, and it's called EIP, and then they are usually have a number after it to indicate like which improvement plan it is.
Gotcha. Okay. And the theory is that the majority of miners will buy into the same EIP XY, 1, 2, 3, and that will be proof of stake, which will then allow for more and more people to build applications, Web 3.0 applications on top of the blockchain, and B, it will allow for increased transaction speed and volume, which is what we, when we think of, hey, when I'm at the grocery store, instead of, paying with my credit card, with my bank, with my bank, I can pay with, my Ethereum wallet, essentially. And I think that and that, I guess that's like generally how I think of Bitcoin versus Ethereum. One being more practical use, application, volume, and the other one being kind of long-term store of value. And I think one distinction I wanted to highlight, which I think is important, is in some ways, the reason that people advocate for any of the cryptocurrencies being used as active currency is because you can track it, more easily, it's more straightforward than traditional banking system. But at the same time, the way the traditional banking system works is that if I have $10 in my my bank account, and I pay with my debit card to buy a water, right? It says that money has been transferred over to 7-Eleven or whatever, but it actually takes like 3 days or even longer for that money to actually get there, which is the same concept as the transaction speed on a node for Bitcoin or, Ethereum or whatever. And all they do is they just transfer the numbers. So the 7-Eleven bank will say, hey, we made $1.50 sale. And the, my Chase Bank or, Wells Fargo or whatever bank you use will say, oh, we just sent them $1.50, even though it's not actually there yet. And so that's why I can see like, hey, I just bought something 5 minutes later, it shows up on my bank account that it's out of my bank account, but it's not really. And so it's just basically a bunch of numbers trading, which you can do in real time versus, or at least relative real time, versus the actual transaction speed. Is that fair? Am I getting that right?
Yeah. And speaking
On that, there's 2 points I want to make. So first of all, I believe that I see Bitcoin more as a science experiment, and I know a lot of people don't really like that outlook on it. It's definitely being used as a store of value now, but I kind of feel like it's being used as something that it wasn't supposed to be. Don't get me wrong. I I I hold it. I'm I'm bullish on it. I think people are gonna keep investing in it, but I don't really see like a practical use case for it ever. Um,
just simply put, and the second thing
is that well, I guess piggybacking off that point before I move on to the second one is there I forget if it's already implemented. It might actually have been implemented this month or something. There's an EIP to actually make Ethereum a like increasing scarcity coin where basically so much of it is like burnt with every transaction that outpaces the amount that's mined. So like the supply will slowly decrease over time. And I think there like you get a better store of value because it's also usable, right? In the case of gold, like I don't know, people want gold because they can trade it and other people will want it. But I don't really see Bitcoin like maintaining that for
a super long time.
I think it'll take a while, but I don't see it being the sheer market dominance that it has now. I could be wrong, but I don't know. I just don't see it being all that useful in the future. The second point I want to make is
There's an interesting concept
of side chains, which are basically smaller blockchains that are not on the like Ethereum blockchain. So in the case of like going to the grocery store, maybe I transfer some funds over to that chain or freeze some assets to prove that I have them then I can use those assets on this other blockchain that's maybe ran just by the grocery store, or maybe like I have my own personal mining equipment that's helping mine for that grocery store, for that chain. And then when I make operations, like my funds could be frozen on the main chain, but transfer instantly to this side chain. And then the transaction speed isn't as big of a deal because they can be resolved at a later time. Maybe, I can make that transaction instantly when I'm in the store, but maybe it's not actually resolved for another 15 minutes or so after I leave the store.
And by resolved, I mean
it goes through on the main chain.
It's in the new wallet.
Yeah, and
there's mathematical proof that we can use to make that happen. I forget the name of the algorithm for it, but yeah.
Gotcha. Okay. So yeah, that's one of the issues that I have with essentially with Bitcoin in particular. Ethereum, I can kind of see its multiple use application and maybe enough diversification of application to where it maintains, a certain level of value. Whether or not there is, or I should say, irrespective of the, inflation or deflationary aspects to it. But that's but going back to your first point, and I think specifically relative to Bitcoin is, in my opinion, Bitcoin only has value as long as more and more people buy it. And right. And now granted, that scale can be significant, right? There's only a handful of companies that have actually put money into Bitcoin. There's only a handful of, individuals, relatively speaking, that have put money into Bitcoin. But when it comes to in 5, 10, 15 years, at some point I feel like you're going to reach saturation, and there's, it's not as if company B is now finally going to say, or company Z at this point is going to be like, oh my gosh, I finally got my hands on Bitcoin, or, oh, I need a little bit more Bitcoin. They're gonna be like, we've got, $500 million of Bitcoin. We don't really need it anymore. But to me, it goes along with, that's why I also don't understand essentially the trading of Bitcoin, because to me, it's like, if the concept is that it's a store of value and it will go up over time, like, why would you ever sell? At least at this point. And that's one of the things why I don't understand all these market sell-offs and all of these swings, because to me, it's like, isn't this antithetical to the very, reason it exists?
You raise an issue that
actually happened with my mining company. There were a lot of people that at this company disagreed with this outlook, and it caused some issues. Is the market was making some moves, and everyone wanted to panic and sell. But the thing that a lot of people don't understand is that's like one of the only ways that you guarantee you lose money, right? If the market is down from where you bought in and you sell, you guarantee that you would lose. Now, like I understand, like, you know, protecting your assets and trying to minimize that, and I think there's a lot of emotion in it, especially like in this area. There's a lot of newbie investors, including me. Like I'm not like a, you know, stock trader expert. I don't know a whole lot about that stuff. Maybe someone who has more expertise could speak on it. I'm sure there's some psychology there, but to me, it just seems like there's a lot of new people in the space that they see red and they panic. And I think there's also a lot of people that maybe are investing more than they can afford to.
Yep. No, that totally makes sense. So kind of then looking forward, or trying to look forward as best one can, is there what are your thoughts on kind of the censorship and or taxing components associated with Bitcoin and or Ethereum? And part of the reason that, and I'll just give you a couple thoughts that I've been having, is one is I can understand taxing, say, Bitcoin profit, because there aren't any applications or serious applications that are being built on top of it. But when it comes to, and again, they would have to do that through the exchange, which is officially filed with the SEC, and, you know, yada yada. But when it comes to the like Ethereum network, that's where I go. It's like, how do you really, you know, like if the value is going up simply because 500 million people are building Web 3.0 applications on top of that, and right, more and more people are using it, then like, how is that the same? To me, it doesn't quite translate in the same way. And so I was just kind of, those are just some thoughts that I haven't reached, full completion on, but
my understanding, in that second case where there's, let's say all of a sudden there's 3 million more Ethereum developers and we reach proof of stake and there's all these cool applications being built and there's mass market adoption. To my understanding, that's not a taxable event. And again, like, I'm not a CPA, I'm not a tax expert. This is just what I understand of. And like I said, there's so much in this space to dig into. Like, this isn't even computer science anymore, right? Like, you have to understand like economics and politics and all these things to be successful in this space. But to my understanding on the tax side of things is that that's not a taxable event. And it's only when you sell an asset that you have to, pay any sort of tax on it. Again, I'm not a CPA, I'm not a tax expert. That's just my very novice understanding of the subject.
Yeah, no. I think you're right on that. I think that, again, my understanding is the same as yours. I think it's more where it, I guess it becomes, I don't know, I feel like it becomes complicated when you run into the question of the government taxing an entity versus like an actual currency or an actual, transaction, so to speak, even if it's selling Ethereum on the network.
And that's something I'd like
to see in the future, actually, is some sort of like smart contract interface that any vendor could implement that would like handle taxes on. So I don't know, in a perfect world, we use Ethereum for everything. Like it's the native global currency. Like, I don't know, you're getting paid for your regular like 9 to 5 in Ethereum. You go to the store, you buy a candy bar using like ETH. And in that scenario, the perfect world would be that there's some sort of smart contract interface that handles all of your taxes for you like that. You don't have to pay TurboTax every year to do your taxes or whatever, right? Like, everything gets taken out the perfect amount. Everything gets, you get any refund the perfect amount, because it's all through this blockchain, very transparent, very programmatic, and all of that is handled for you. Maybe that's a little naive. I know people are thinking more like, in a decentralized land, everything will be a little more like anarchist, but yeah. I don't know. That seems like the perfect translation of like why this would be a good argument for governments to use, because I would imagine, the IRS and entities like that are just massive and cost so much money, and it would be so simple just to automate them using something like smart contracts.
Yeah. Gotcha. Okay. Yeah. And I think the other part that I've gotten, and maybe this is why and where a smart contract would be helpful, is like, if I sell my Ethereum, but I transfer it into Bitcoin, and then I use Bitcoin to buy Dogecoin, and then it's like, and a US dollar never left or entered my, my bank account, then like, how are you supposed to tax that and track that sort of thing?
Yeah, I think my understanding.
Each one of those is some sort of taxable event, but again, I don't know. I personally don't trade cryptocurrency, so I know a lot of people that do. I just invest, but I don't like actively day trade or anything.
Yeah. Yeah. No, same with me. But it's just like, it's more that practical use going forward. So then the other side of that is like actual censorship, yada, yada, yada. Do you have any thoughts on, like, obviously today being a great day because, well, relatively speaking, if you want to buy the dip, because China announced, essentially a crackdown on its central banks being allowed to interact with Bitcoin and other cryptocurrencies, and which apparently they've done in 2013 and 2017. And so it's kind of like they're doing it again, maybe because like they don't have the infrastructure to tax it, to manage it, to oversee it. And then secondarily, or maybe not secondarily, but equally secondary or equally primary, is that, there's been talk about them building out their own digital currency, which would track against, their own nation's currency and yada, yada, yada. And therefore, like, they can drive up the value of that one because, hey, you should own this one, not that one. But do you have any thoughts on that going forward? Because, so far, and I think, and generally speaking, it's going to be a big question, kind of a constant back and forth, because, all of the governments, generally speaking, in the world, certainly the US government, is operated and run by people that do not understand technology, barely understand Web 2.0, let alone Web 3.0. And they don't have the technical chops to be able to even begin comprehending, let alone executing on legislation and then executing on, the operations of managing something like that. And so they kind of, like a Janet Yellen, right? It'll come out and be like, complain about Bitcoin. But like, beyond complaining about it, there isn't actually anything that they can do. And their only argument for taking action on the negative is that, hey, people lost their money because Elon tweeted and we let them buy Bitcoin, which to me, at least in America, is like saying, it's, we're going to prevent you from lighting a firecracker in your house. It's like, don't do it. And everyone's been telling you not to do it if you can't afford it, if you're not willing to, it's investing. And then the on the positive side, or I guess the negative side, or the positive side of adoption, is that they can tax it, more revenue, blah, blah, blah.
Yeah. So
I guess let me give my pitch to those old folks, all the boomers out there. Here's why you should let this happen. So and like, humans aren't perfect. Okay, there's a lot that we do, especially in our current day legislation, that's up to, I don't know, up to bias, right? There's a lot of bias everywhere. What a blockchain would allow us to do is codify these rules. We could literally program our like government laws into a smart contract, and they would be strictly enforced. There wouldn't be any pushovers because everything would be transparent. If someone gets a workaround, everyone can see that happened. So I think it's in the favor of some of these people. Well, I wouldn't say that. I think it's in the interest of everyone that everything is transparent. The flip side is, we all have some opinions on people we think are dirty politicians and do things behind closed doors. I would say in that situation, it negatively affects them, very directly negatively affects them. So I think what it would allow is for those people to be better at their jobs, right? We would have more, I guess, developers working with those types of people to implement this logic where we can codify these rules. It's very hard because basically the motive there becomes, we need to digitalize everything. Everything in the real world needs to be represented digitally in order for that to happen. Yep. All the edge cases and bugs need to be worked out, yada, yada, yada. So it's difficult, but I could see a world very far into the future where it's a possibility. Do I think it's going to happen? I don't know, because I don't know, people tend to mess things up. So I don't know.
Gotcha. No, that's I like that. I think it's a good summary and a good warning on both sides. It's kind of like you hope for the best, do your best from an investing and, studying and time management side, and then you kind of have to let the world's going to run its course to a certain extent or another. Are there any other components to the whole discussion here that you feel like are important that we should have covered that people, are probably asking that I forgot to ask?
I think from a basic standpoint, that's good. There's some more advanced topics. Maybe if we decide like part 2 or something, there's more we could talk about, but it's a little high level. I don't know if like the average like viewer would enjoy listening to that.
Okay, so I like that you said that, because as we were talking, and even as I've been thinking about this more broadly, is to what extent is it useful, in your opinion, to endeavor to understand the million factors of nuance in the cryptocurrency world versus saying, here's 2 or 3 big ones, here's maybe 1 or 2 fun ones. I'm putting money, based on my own personal, investment plan, desires, whatever, wants, greed, whatever you want to call it. And I'm just kind of YOLOing based off that. Because I'd certainly, where I felt to a certain extent, and like, I have a general grasp of tech and, how it can work and blah, blah, blah. But it's like, dude, at some point it's just like, is this even worth it?
Yeah.
I think so. One of the problems is that startups and new technology, they tend to solve technology problems, right? You see a lot of startups that are trying to like improve something that is like very obscure and technical, and that's what this entire space feels like. It's very tech. Like I know it's a technical field, but it's it feels like it's aiming to improve technical aspects of technical fields, and that can be hard to understand. Now, what I would say is, you don't need to be a software developer to read a white paper. You might have to do some Googling and figure some things out, and you might have to ask questions and talk. You don't need to be a software developer to like join a Telegram group and read opinion articles or like watch YouTube videos, right? Like it's definitely possible to do your research, and there's a lot of great beginner friendly assets out there that can help you learn more. I think what I see a lot of is just people doing technical analysis in more of like a financial world where they're looking at charts and seeing what the market's doing. But like, I guess that's okay if that's what you're into. The problem is that I see a lot of people that don't really know much about that getting into that now. And that seems to me kind of dangerous. Whereas I think those people's time, unless like they're actually trying to learn how to do it, and that's, what they want to start doing, I think those people's time would be better off spent, reading, doing more research on what the actual technology is trying to solve. Because that's what's important to understand in this space. And some of those white papers, yeah, they have a lot of language and they're kind of hard to understand. But I think the average consumer, if they were to put their best efforts forward, they'd be able to understand a little more than they think they would.
Gotcha. Okay. Good to know. I'll keep trying.
Yeah, and
it's difficult, but there's plenty of YouTubers, like there's plenty of YouTubers in this space. I see people on TikTok all the time now explaining some of this stuff. And I think is what's important is to understand, like, do I want to more understand why the market is buying this from a sense of like looking at these charts, or do I want to understand the foundation of this technology? I think those are kind of the two pillars of what people are getting into now. And what I see a lot of is people who want to invest long-term looking at charts, and people who want to invest short-term looking more at technology, where in my opinion, those two need to be swapped, right?
Sure. That makes sense. Okay, cool, man. This was super helpful. I definitely appreciated it. It helped me think through it. The first half certainly helped me clarify what I kind of like generally understood based off, the research that I've been doing, but it was nice to like actually talk it out a little bit with someone who knows something about it more than I do, certainly. So thank you. I appreciate it. This was fun, and I'll let you know about part 2. I'll have to keep doing some research, and we'll see what happens.
So, okay.
Cool. All right, everybody. We will catch you next time.